Good day, everyone. Welcome to a presentation Adversarial Input Detection using Image Processing Techniques. I am Nafis Sadman, and I'll be presenting on behalf of Dr. Gupta as he is absent for personal reasons. All right. So, what is an adversarial attack? Basically, it's the manipulation of training data on machine learning caused by machine learning models when detecting some kind of labels from an image. This can be on image data, and this can be in any domain. Data can be on natural language processing domain, where you can manipulate the sentiment. And for image, you can change whether it's detecting a label. There are a few types of attacks. There's a pausing attack, there's an evasion attack, and there is a chosen attack. Here's an example of the adversarial traits. So we have a clean image, then we have FGSM, which is the first gradient descent method, then we have JSMA, the Jacob saliency net method, and we have CW, which is an attack proposed by Carlini and Wessner, and we have a diffpool. So these different types of attacks have different types of noise manipulation and properties that change when they attack an image input. Here we have an example. For example, we have an image with B, and this image is not attacked by any of the attacks that we have talked in the previous slide. So this goes through some image processing techniques, and we have a cleaner image compared to the one before. And after that, we can see the pixel differences, which is very, and the histogram value will be like very clean. But we have another image A, where this one is attacked by any of the techniques attacked by the adversarial attacks discussed before, and this goes through enrichment techniques, and you can see the pixel differences is much higher compared to the one above, compared to the cleaner image of B. And this will be misclassified. For example, this A will be either classified as E or some other alphabets. So this is confusing the model. We have another example with a digit called 7. So this 7, you can see after some processing techniques, the pixel difference, we can clearly recognize this is a digit 7. But for 4, this has been attacked by FGSM. After some pre-processing techniques, you can see the final result. This is hardly recognizable to those who confuse the model. So this is basically a flowchart of what we have seen just a slide before. So we have a clean image set and we have an adversarial image set. Now this will go through some IPTS sequence, that is image processing technique sequences, and eventually we'll calculate the pixel differences between the original image and the image after the processing. And we can compare them and see how vastly they differ from each other. We have more examples over here. So we have the original images and the attacked original images. You can see, and then we add up to smoothing. You can see the pixel differences. We can add some bilateral smoothing, and we can also see the pixel differences from the original to the corresponding attacks. We have more examples on digits. We can also add another smoothing or thinning layer, and we can see from the original, and we can compare from the original set to the eventual final pixel dataset, and we can see how altered or how distorted they are from the original and the final image after the attacks have been implemented, which eventually leads to misclassification. So let's talk about our methodology. So we have a test input that goes through a sequence of image processing techniques. Now, this is first chosen random, and with the help of genetic algorithm, we can find out the most appropriate ones, which cover all types of attacks and selects them dynamically. This goes through some IPT operations, and their matrix calculation. Now, based on this matrix calculation, we are building our ML model, which will do the prediction of the labels. We are also maintaining a security management database, which helps to improve our genetic algorithm in producing a better set of IPTS. To summarize, we have some image processing techniques, and with the help of genetic algorithms, we will have a sequence of the IPTS, and we randomly choose a set from the IPTS. And from this section, you can see that each attack may require 2 or more of the sequence image processing technique sequences. To actually implement the methodology, we have used 3 different datasets: the image dataset, the CIFAR, and the ImageNet dataset. Okay. So we have compared our proposed model with other models currently used to detect such kind of attacks. And you can see, on average, we are actually outperforming other models on the corresponding attacks. To end our presentation, I would like to say that our model is working against adaptive attack. Our model is dynamic. Our model does not sacrifice machine learning models' efficiency at all. It can identify the attack types as well. And it is not platform dependent, it's cross-platform, and it works both for black box and white box attack. So thank you everyone for listening to the presentation, and if you have some questions you can ask. I'll let you end the presentation here. Thank you.